What's up, everyone? J2 Tutoring back at it with another video. I'm Jaden Barish, your host. And today we're going to do something very related to the previous two videos. Not quite exactly, but take it up a notch. It's going to be a little bit more graphical this time, instead of as algebraic. Originally, we were doing factoring and some quadratics, and we're kind of going to put all that together. It's going to be more toward the factoring side than the quadratic side. But let's get into it, because a lot of people think, all right, well, we have all these calculators to graph all these things to really see what these functions look like. But I want to teach you a good method of figuring out what they actually look like by hand, right? And I'll show you with Desmos afterwards because you can use Desmos to check your answer essentially. But when you're drawing these large polynomials, and I'll do it in factored out form first. So like if you have something like this, right? Let's say you got like, you're given this, and if you're taking pre-calculus, this comes up a lot. Okay, this comes up a lot. It's definitely a big part of the unit, definitely gonna be on one of your exams. Let's start here. Let's start simply here. The point is, right? And honestly, we'll set it equal to, it doesn't need to be equal to, it could even just be an expression. Now the idea is that you have a function like this, right? And you're like, all right, well, how do I draw it? Well, the first thing you want to figure out is what are the zeros, right? So when we draw this out, we want to figure out when does it equal zero? Because then we know from the previous video that would basically be an x-intercept, and that's where you start, right? These graphs you have to draw, you have to go through x-intercepts always. So you're thinking to yourself, all right, well, we got -3 as 1, right? Because if you put -3 in, it's going to be 0. Y is going to be 0. If you put 5 in, y will be 0. And if you put 4 in, y will be 0, right? That's where we begin, just like before. So we'll just not draw into scale, of course, but, we'll just, we'll put these numbers in. So we're starting here. This is your starting point. You already got half the battle, kind of. But now you're like, well, how do I draw the line itself? Well, the first thing you want to look at before you look at anything is, after you find the zeros, is the degrees of each of the factors, right? And I'll tell you this now, there are three types of points that you can have. You can have a normal first degree one. You get a first degree, okay? You could have second degree, and this is called the tangent point. You hear your teacher say that. And you have third degree, which is called the terrace point. Now, keep this in mind. You're like, well, what if you go any higher than that, right? If it's a multiple of any of these numbers, it's going to be around that, the same as that. So if it's an even number, it's going to be tangent. If it's a multiple of 3, it's going to be terrace. And if it's neither, it's first degree. So if you get something like 11, then you're just going to go through the point, essentially. So that's kind of how you figure this out. So in this case, you're thinking, all right, well, all of these zeros, so to speak, all of these zeros have a degree of 1. Right? So this one's pretty simple, okay, in that sense. When you have a first degree, you just go through it. I'll put GT. You go through the point, essentially. That's how you figure that one out. Tangent, we call it a bounce, and I'll show you how to do that in a second. You call that a bounce point. And terrace, we call it a terrace point because think about what you're doing on a terrace, right? You sit on a terrace. You're essentially just sitting. I'll put an L there as a person sitting, okay? So, and I'll show you how that's done in a second. But then you're like, all right, I know how to go through the point, but where do I start? Well, the final piece to this puzzle is really end behavior. Okay, that's how this ends. That's how this ends. End behavior. Okay, you got to figure out where you're beginning. Are you starting at the top or the bottom? That's the name of the game, right? When I'm going, and I like to go left to right. That's kind of how I go. So if I'm coming in from the left and I'm going to the right, am I coming down or am I going up? That's your number one question, right? Of course, this isn't going to be a perfect graph. I'm no artist, but you can get a rough sketch. So what do? You plug in random numbers, man. I mean, that's really how this works, right? So, okay, if I plug in negative infinity, right, over here, and I'm coming, am I going down or am I going up, right? That's the idea. And the way to really figure out is, yeah, you basically just start with, negative infinity. So if I plug in negative infinity in here, you know, it's negative infinity, right? If I plug in negative infinity in here, it's negative infinity. And I just want to make a side note here. I'm going to write this notation wise. This is not mathematically possible because infinity is not a number. You can't multiply infinities. But for the sake of figuring out the sign of this, I'm going to put it in here. But just know, like, you can't do it this way. But think of it this way, right? Think of it like this. Negative times negative times negative. That'll give you a negative, right? So that means that you're coming from the negative. It's not that you're going down, it's that you're coming from the negative. The y is negative. That's where you're starting as you get infinitely small. So, should move this. That means when you go through here, you're going like this. It has to go down, right? And then you look at what type of point -3 really is. You're like, all right, well, it's first degree. So you're just going to go through it, right? And then you hit the y-intercept, which you don't know yet, but we'll get to that too. And then you follow its normal trajectory. You're like, okay, well, it's got to go down. Why? Because it has to hit the x-intercept. You got to go through it. So you just follow the normal trajectory. Okay. We look at 4. We're like, all right, first degree. You go through it. All right. And you're like, well, it has to go back up at some point. I don't know exactly where, but you have to hit the 5. Okay. It's a first degree, so it has to go up because it's got to go through it. Now, we can check that it goes up. Why? Because when it goes up, you plug in infinity here and you get everything's positive. So given that everything's positive, you know, you get going all the way up. They're probably like, well, isn't it always going to be everything's positive? Always everything's going to be negative? No, because when you get the squares that come in, and I'll do that in the next question, you start adding these different exponents, the negatives start canceling out. So I'll give you an example. So like I'll even use the same factors. I'll use the same exact factors, but I'll change the degree of each one. So like if I did, let me do something like this, man. Let me show you something. Let me show you something cool. If I get something like this, right? No, we'll do a square. So this changes the whole game because when you do something like this, now I didn't get the y-intercept. It's not as important. How do you get the y-intercept? You just plug in x for 0 for everything and you figure out what it is, right? So for this one, just for completeness sake, if I plug in 0 here, you get 3. It's easy to find. That's why I'm, you know, but -5 and then -4. So you end up with 60. Essentially, the y-intercept is 0, 60. Now, obviously, none of this is drawn to scale, as I said before, but like this point would be 0, 60. Okay. And you're good. You're lucky it's positive, right? That's a good check too. So that's what I was saying. You're at -3, right? You're at 4, and you're at 5. Okay. Now you know that these are your points. You're like, okay, well, where am I starting? Right? And you can take this from either side. I just take it from the left. You're like, all right, well, if I plug in negative infinity here, it actually goes positive. So you're at positive infinity here. If I plug in negative infinity here, you go negative. If I plug in negative infinity here, it goes positive. So here it's actually negative. Okay, just by happenstance. So you're starting going down as you get infinitely small. But now that's a square. So now this is going to bounce. You see how it's like a trampoline? Boom. It just bounces right back down. It doesn't go through it. Then you're like, all right, well, but we got to hit that 4, right? It has to hit that 4. So you naturally just go up. You don't know where that y-intercept is, but you know there has to be one. And now it's going to be negative, and we're going to check that in a second. And then you're like, boom. Oh, I missed it. But that's another bounce, right? Because it's a square, so it's another bounce. And then if you get to here, and you know it has to go back up because it's a terrace point, or because you have to hit 5. But it's a terrace point, so what you're going to do is you're going to sit down. It's like that. Right? And you could check the end behavior too. If I plug in infinity, infinity is there, that's positive, 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 we're going up, right? Now you're probably like, well, when is this side negative? Well, if I threw a -1 over here as our like, coefficient in front of the whole expression, then it would be negative if you plug it in. But that's essentially how you find all these end behaviors. Um, and that's how this is drawn. And you could even like, here, I'll even show you. I'll get out of the whiteboard for a second just because I think screen sharing is a good idea. I'll even show you. So if I can change my, I want to go to Desmos first. But I just want to show you. I may not be able to screen share. There we go. Okay. Yeah. So now, yeah, there we go. So now we're here, right? And originally what we had was something of this nature. I mean, we had x, it was, I was doing this before, but you have x plus 3, right? And that was squared. Your terrace, you had x minus 5. You had x minus 4, which was also squared. And then you had x minus 5, which was to the third, right? That was what we had. So now you're here, right? And you're like, okay, but what is he talking about? Look at that. See? Okay, you go to 5, right? You zoom in, there's the sit. You see how it's sitting there? That's what I was saying. And then you come here and you're like, all right, right? We don't know exactly where that bounce is, right? But that's generally how our thing looked. And right here, look at that. There's the bounce. Boom, right back down. And if you zoom out even more, all right, it dips really far down. That's hard to see. And that's because the y-intercept is really far down. But if you look at this, there's your -3, and there's your bounce yet again. So these patterns are very true. And honestly, I should even show you that it's the same, even if it's like if it's 9, right, for x to the fifth. Now this is gonna spread everything out, of course. It's a little bit harder to see. Yeah. But notice you're still sitting. The only thing that this exponent does when it's a multiple of these numbers, 1, 2, or 3, is it makes it more extreme. It makes the characteristic more extreme, essentially. Um, Basically, that's what it does. So back to our whiteboard to close it out. I just want to show you. That was essentially what we wrote here. That was how we wrote our graph here. So I just want to make a point here that you don't need these graphing calculators necessarily to make these graphs quickly, right? It might even take you longer because look how long it was taking me to navigate Desmos, because I know on the SAT you get Desmos and a lot of these exams on pre-calc you get them your calculator. It's hard to navigate them sometimes. So being able to sketch them just to see how they look like, what they look like could be really helpful. Sometimes teachers don't want you to use the calculator. They want you to learn the skill. So I just wanted to present this to you. I'll go into parent functions and like asymptotes and all that next time because that's even more graphing, but that gets even more complicated with especially with rational functions. But yeah, that's essentially this video. I hope you enjoyed it. If you want to know anything else, subscribe to the channel and also, go on jttutoring.com to get some more tutoring and help. All right. Have a good night, everyone.